Hi, my name is Markus Nispel. I'm Vice President Solutions Architecture and Innovation at Extreme Networks. Solutions Architecture and Innovation as it relates to our own products and portfolio elements and how they work together, as well as how it integrates with technology partners. Purview details. I expect questions. So far we didn't have any questions. I want criticism and a lively discussion for sure. Whiteboard will be used as well. So I have a few slides, but the slides obviously most of the time don't go into the details as most people want them to be. So whiteboard is ready. So you've seen that slide, obviously. The change in the IT application landscape, the transition to more cloud-based services resulted in a unification of the presentation layer. So most applications use a browser to be accessed, as well as a unification of the transport layer. And as we all know, traditional network devices become blind towards those applications as they are all wrapped in a specific set of ports, whether it's 8443 or whatever, doesn't really matter. So Purview and the underlying technology components really solved that problem to regain application visibility and subsequently control at a different scale point, which is important, at a different cost point, with different speeds, and at a different point in the infrastructure compared to most or all existing solutions out there. So obviously it's not really new that you have network devices like next generation firewalls, WAN optimization products, etc., that provide a certain amount of application visibility, but you have to do that at a cost and at a burden. And the cost is the cost of the product itself. The burden is the traffic needs to be funneled through that system itself. It's typically limited in scale in terms of number of flows as well as throughput, and you obviously deploy those devices at choke points in the infrastructure, and you don't have those pervasively deployed in the infrastructure. And our solution addresses all of those components. We do it at scale, so it doesn't really matter how many flows you will see in the infrastructure, and we talk about that. We do it at the same cost points as you provide traditional switching products, so there's no additional cost associated with it. And as we embed it right into the existing switch infrastructure, there's no speed or throughput limitation. Obviously you have your product throughput limitation, but beyond that there's no limitation in the architecture itself. And you can also deploy that solution again pervasively. You can start at choke points. Yeah.
So how are you gaining access to the port 443 traffic, the SSL traffic? How are you looking into that?
Yeah. We are getting to the fingerprint technologies as well, but obviously encryption or encrypted traffic is a component that you need to have, you need to take into account. We don't decrypt SSL traffic, but you get most of the time enough data out of the unencrypted part of an HTTP header to make your decision on what application is included in that traffic stream. So using a host name, common name, reading the SSL certificate gives you already a good idea. Obviously, if someone is trying to do something bad and is trying to wrap traffic into an SSL tunnel that we can't detect, there's nothing we can do about it. But again, we are not meant to be a security product. We are an application analytics product, and obviously there are applications everywhere who try to obfuscate themselves. On the other hand, there's a certain amount of statistical analysis that we can do against the header to figure out certain things. So that is also part of the product itself. So the fingerprint engine itself, getting into details later on, is derived from our IDS product that we had in our portfolio since the late 90s. So we have a good idea on what needs to be done to track those guys like Skype, BitTorrent, and other applications.
So I assume there's a subscription component to this.
Yes. Yeah. But we're getting into details. So, but that's the idea, and it interacts with the infrastructure. And it interacts with the infrastructure based on what Eric mentioned, with infrastructure components who use a different forwarding paradigm than traditional switching products. That is really important. So our forwarding paradigm, our architecture itself is flow-based. So really internally, the ASIC architecture uses a flow-based forwarding paradigm that allows us to do certain things that you don't get with traditional architectures. So traditional forwarding architectures that are longest prefix switch based and use TCAM technologies won't be able to scale to the level that we scale in terms of application flow detection and analytics, and it doesn't give you the ability to peel off a certain level of packets that we need to provide the DPI inspection on top of that. So that is really important, and around that topic as well, we need to define what is a flow. And flows became en vogue again as we talk about SDN architectures, because I think the industry figured out that flow-based systems provide better control in general. And we always believed in that. That's why we never abandoned our flow-based ASIC technology, because we always saw that you can do more with a flow-based architecture and a flow-based system than with a traditional packet-by-packet based forwarding system. But there are also some challenges associated with that, as always. So it has always pros and cons, and that goes back to how many flows can you manage and how do you manage those flows. But we are getting to that as part of the presentation as well. So the solution components, you need a data collection and subsequently policy enforcement engine that is flow aware. That's our CoreFlow2 based ASICs that are deployed in our system. You need our management system, and you need the Purview analytics engine, which is the actual DPI fingerprinting engine. But it does a little bit more than this. It needs to stitch together different data sets and roll them up and provide them upstream to the management system as well. So we will go into details. I basically have 3 sections, one about ASIC, one about management, and one about the engine itself. And again, we also have our whiteboard.
So when it says works in any network environment, what do you mean by that? Because what I'm hearing is it works in any CoreFlow2 extreme network environment and only on those devices.
Yes and no. Yes.
Okay.
It works in 2 things. If you have an existing CoreFlow based infrastructure in place, then it's obviously easy because you just turn it on and you're ready to go. If you don't have a CoreFlow2 based infrastructure, then we still can deploy those components as sensors out in the infrastructure. So you either use a tap or a port mirror to get data to that system, and then the whole basically processing takes place as well. Even that switch doesn't forward the packet, it still will do the packet mirroring and produce the net flow data that we need to do
that kind, they almost become like probes.
It's a probe. It's a high-speed probe. It's a pretty cheap probe, actually. So we can provide 10, 40 gigabit per second inspection with our smallest switch, which is in the range of 20 to 30 grand US list price, which is pretty cheap for a 10 or 40 gig DPI solution. Yeah. So we need to take that into perspective.
So these probes, you before you said that it would forward the first 15 to 30 packets, or somebody said it would forward the first 15 to 30 packets of a flow. Will those probes do the same, or will they forward?
Yes.
Okay.
Yes, yeah. And that's basically the trick, how you get scale in terms of your DPI infrastructure overall, because your DPI engines, that's what's really important. They typically run on an x86 machine, and you can't inspect terabits of data with an x86 architecture. But if you have a flow-based ASIC architecture underneath that is able to detect new application flows and then peel off these first few packets, then you can provide the magic, so to speak, in terms of scalability. And in fact, by default, our configuration recommends 15 packets. And what you will see is that for a lot of applications, you need even less than that. That is also interesting. So detecting an application doesn't require a lot of packets. Obviously, there are some applications where you want to see more, but there are a lot of application flows where you need dramatically less packets. Yeah. And also then the data reduction rate that goes along with that is pretty substantial, as you imagine you have an iSCSI session between two servers that lasts for 2 days. transmitting 20 terabyte of data. What the DPI engine really sees is 15 packets, that's it. And a few NetFlow records subsequently, so we can sum up the whole thing. So you end up with the right statistic at the very end of the day. So depending on your traffic profile, the data reduction rates, and so the scalability that we can achieve is pretty dramatic. Yeah. Okay, that's how it works. So the engine itself gets the first few packets along with NetFlow data. It's also important to note, as we are using flow-based ASICs, we do produce non-sampled NetFlow records for all flows throughout the system. That really means we do that for hundreds of thousands and millions of flows in a non-sampled fashion. That is also dramatically different than a traditional TCAM-based architecture, which doesn't have a notion of flows and which has a very limited capability in terms of data and statistics collection. So again, that's a dramatic difference here in terms of scalability and architecture. That is important. The engine itself does a DPI, data extraction, stitches those things together, and then we roll it upstream to one fabric control center. Yeah. At each and every layer, we also have integration capabilities with other IT systems. I'll talk about that later on as well. So we see already first customers picking up the solution and using our APIs to integrate that kind of data in subsequent IT systems and processes to crunch the data and provide even more intelligent statements and around the data that they see, and really turn the data that they see into information and knowledge that is coming out of the network. Okay, I said we have three different components here. First one is the ASIC technology itself, CoreFlow2. And that goes back to another discussion that we already started here. So how do we provide application awareness in a flow-based environment? And what does an application really mean, and how it's represented in such an architecture? So, and I mentioned it already, that somehow relates to SDN as well. So SDN is to a large degree all about applications being able to provision services inside of the network infrastructure itself. So you have, for sure, you have an API into the network infrastructure that allows applications to do something in the network itself. The problem so far with most SDN deployments and solutions that we have seen so far is the fact that this whole controller architecture to a degree helps from a provisioning perspective, but as the apps still need to know too much about the underlying network infrastructure, there's still too much complexity at the northbound API layer. And you can basically avoid that by abstracting the whole network infrastructure towards applications in a way that you are also application aware at your data plane layer, which is like totally different than what you see in typical SDN deployment. So at this point in time in an SDN scenario, applications need to know how the network infrastructure, how the topology looks like, and they need to know how they are connected to each other. So applications need to know a lot, basically too much about the network itself. If the network itself knows how an application looks like, the application doesn't need to know about the network itself. So it becomes much easier to provision services for certain applications inside of the network infrastructure. So that's a different spin, and it's an option on how you can look at such an architecture. Problem that occurs as you do so is with traditional ASIC architectures that you would end up with a lot of application flows, so to speak. As an application is defined, as we just talked about, at a level that is even higher than layer 4, unique applications and unique application flows need to be presented at the data plane layer as well. So you end up with millions and millions of flows. Yeah. And traditional architectures don't really support that. If you look at today's commodity ASIC, TCAM-based, you have somewhere in the range of 2,000 to 4,000 flows per ASIC block available to do certain things. That is not a lot if you look at the flow requirements. So what you typically can expect as you define your application or your flows in a very granular fashion, so up to layer 4, and you don't do any wildcarding, you can expect up to 1 new flow per second per client in your network. So if you have a network with 100,000 clients, you will see 100,000 new flows per second in your network, plus all of the flows that did not age out yet. So you potentially end up with millions of flows in your network infrastructure. And how do you manage those? In today's SDN architectures, what is done, what people typically do is you either pre-provision those flows, but you don't provision millions of flows, and you start to wildcard those flows, or you reduce your tuple depth, so to speak. So you go back to layer 3 or layer 2, and then you just talk about end system connectivity, and you don't talk about application flows anymore. So you don't have application visibility anymore in those scenarios, because you're just seeing endpoints being connected, and you provide statistics based on endpoints being connected. And that's an issue. CoreFlow2, on the other hand, is inherently flow-based. So our largest system today is able to support up to 100 million concurrent flows in the system. So that sounds really weird, and you would think that I'm mixing up stuff when I talk about 100 million flows versus 2,000 to 4,000 flows. But it isn't. It's the same definition. It's the same flow. It's just a matter of, as we are providing an exact match on all tuples within the IP header, and what else you want to add to it, shortest path bridging, Q&Q, whatever, you end up with a lot of different tuples and a lot of flows that we are able to handle, manage, and provide statistics upon. So that's the only solution that really provides application visibility at that level. Yeah. All other. Yep.
Can you talk a bit about the tuples that are supported, because this is a kind of a big deal?
Yeah. That is a really big deal. So I can't disclose too much, but I can tell you that inside of our ASIC technology, a connection which is equivalent to a flow can exist of almost 100 bytes, and we can randomly pass not randomly, also restricted, but we can pass out of a packet header or out of a packet, out of a few hundred bytes of a packet, a connection, a flow together that consists of almost 100 bytes. So you can easily combine IP version 6 with SPBM and GRE and VXLAN and construct your own flow if you want to.
100 bytes does give you quite a bit of flexibility.
Yeah. Almost 100 bytes. So I can't disclose too many details, but it's in that range. So it goes well beyond all of the headers that you typically can stuff together today, and still have some.
As long as you can support what's there, then yeah.
Yeah. That also allowed us, for example, in the past to support with an ASIC that we designed a while ago, new protocols like SPB, just with a software upgrade, because we just changed the classification and reframer capabilities in the ASIC architecture. So we have an ASIC solution that typically lives much longer than a traditional commodity ASIC solution. Yeah. That gives better investment protection and more flexibility on our side. So all of those flow capabilities, it's a flow-based capability, but it's also the flexible classification and the flexible reframing engine that makes up the solution. Yeah. On the other hand, you have to manage those flows in the system itself. That also means you need a highly scalable and distributed system architecture to manage all of those flows in the system itself. It also means you can't really externalize all of those flows and the flow management externally. Yeah. So you have to have a lot of capabilities, resource capabilities in the system itself. Any questions about that? And all of that is obviously done without performance impact. As you have a flow-based system, you just you have counters for each and every flow in the system itself. So counting packets and bytes as part of the forwarding process doesn't impact your performance. It's automatically there. Yeah. So again, a big difference. So we think we are in a pretty good shape here from an architectural perspective. Yeah. Okay, good. I was tasked to reintroduce myself in the next section as you don't have any questions about the ASIC technology itself. So the second component to the solution is One Fabric Control Center. My name, Markus Nispel, Vice President, Solutions Architecture and Innovation. One Fabric Control Center is the second component to our Purview solution, which basically provides the presentation layer of the application data, as well as the ability to integrate with other IT systems via a set of open APIs, which are mainly XML SOAP based, but we also have different capabilities here as well. We talked about application analytics. That is one very important component of the solution. On the other hand, before we focused on applications itself and the ability to detect applications beyond layer 4, we already transitioned our management paradigm away from a traditional network management paradigm into a more end system and user-centric management paradigm. So that means that our network management system is also managing network components, but more importantly, we focus on the end systems that are attached to a network infrastructure to use that information to provision the network infrastructure automatically. And that sounds and smells a lot like SDN. We started with that in 2008. And we evolved that technology over time. But we just figured out that's a very good abstraction model to use the endpoint to do so. And as you use the endpoint to do so, you are totally dynamic. As the endpoint gets connected to the infrastructure, you just provision policies on the fly and in an automated fashion. And to also offload the IT, the network team itself from doing the initial provisioning, we developed a set of APIs that allowed us to integrate with other IT systems to automate that workflow and also delegate the provisioning of network services to other IT teams in the organization. And again, smells like SDN. We didn't call it SDN. We probably don't call it SDN today, but it is to a large degree an SDN solution from a provisioning, automation, and orchestration perspective. And I will give you some examples on what you can do with that technology. As you combine it with application information, it obviously becomes even stronger. Yeah. I was also surprised. I watched one of the NFD videos the other day. We had a small startup also from the Boston area talking about those kind of things. They called it affinity networking. They had a better name than we had, but it's basically the same concept, the same idea, and it's pretty close. And I was always surprised why on all of my blogs on SDN Central, someone from these guys made comments about, yeah, that's just right, yeah. After I figured out what they do, I know why he always was so positive on my blog. So anyway, so it's basically the same. It's not the same, but it's a similar approach, obviously, to the same problem. How do you manage the infrastructure as a single entity and provide a provisioning scheme that spans the whole infrastructure from the access layer down to the data center? And that's what we do as part of our One Fabric Control Center solution. So you might have recognized One Fabric Control Center. We are mixing up NetSide and One Fabric Control Center as brand names. The product itself is called NetSide, but NetSide itself is not the solution here. NetSide itself is augmented with our network access control solution with Purview and other components, and that ecosystem that makes up One Fabric Control Center. But One Fabric Control Center is characterized by the fact that it's a single management database, it's a single server, it's a single system, and it's a single point of configuration into the network infrastructure, and a single set of APIs that is provided into the network infrastructure. That makes up really One Fabric Control Center. Right. Another component to the management system itself is our policy control architecture that also evolves over time. Obviously, we came out with that quite a while ago, being able to provision network services in terms of VLANs, access lists, QoS, rate limiting, rate shaping, mirroring, syslogging, redirection, and things like that. And obviously, as we are evolving Purview, that policy framework will evolve as well. And we're using that at the access layer as well as the wireless access layer as well as within the data center. So, as I said before, we moved away from traditional network management to end system centric management, and one advantage that we will gain out of that is the ability to track and monitor end systems on the network in real time. So another key component to One Fabric Control Center and our access control solution is our so-called end system cache. So the end system cache is basically a real-time inventory of all end systems on the network. It's 50 data sets deep. So we track MAC, IP, user, hostname, device type, location, timestamps, and other attributes. And it can be up to 100,000 end systems wide on one server. So it's pretty substantial, and it's updated in real time, and that gives us the ability to locate users' devices in real time and stitch other data like our application flow data to it and provide even more valuable information, which you will see in the demonstration as well. Keeping in mind privacy concerns here as well, the identity information is not mandatory, so you don't need to stitch that together. You can basically either don't combine the data at all, or you can obscure it if you want to. Okay, the system itself, as I said before, it's a single point of configuration into the infrastructure, but it also has a set of APIs layered on top of that that allows other IT systems to manipulate the network configuration. And we typically, as we have done that for quite a while, started with XML SOAP-based APIs, but we quickly evolved it into a system that allows us to integrate with various IT systems using various different protocols. And to do that, we added a layer to our XML SOAP API layer that allows us to manage data persistence between different data sets in different IT systems. So as we integrate with VMware, for example, in the data center to expose network provisioning capabilities to the system administrator, we are using the vSphere API to do so. On the other hand, and the vSphere API is based on an XML SOAP scheme. When we do it with Microsoft, using a different protocol, as we are integrating with Polycom, for example, we even use SNMP to integrate. So that integration layer that we provide on top manages those different protocols, those different data sets, and provides data normalization and automated updates between those target systems. And that's how we allow the endpoint management admins, whether it's mobile device management, whether it's a configuration management database, whether it's Microsoft Systems Center, whether it's a next generation firewall, or whether it's a VM administrator in the data center, to request and provision network services without the network team being involved. So another part of our capabilities here, that API layer and that very flexible API layer in that space. And again, as I've seen that other webinar, I was pretty surprised that their architecture is pretty similar to what we do here in that space. Yeah. Okay, but we not only do that for endpoint related data, so all of the provisioning can be based on those attributes that are tracked here in the system. So whether it's device identity, user identity and role, whether it's location, time, device type, etc. So those are the typical attributes that you can manipulate from an external IT system. We also provide the ability to expose our Purview related data to other IT systems as well. So we have already an integration with Splunk Enterprise available as we provide that data using syslog capabilities, but also we have again an XML based API providing JSON data upstream to random applications. And what we do see is that over time there will be a whole new ecosystem of technology partners that leverage similarly to our provisioning data, that leverage that application data for further analytics. And even the initial NFL announcement itself brought up a range of marketing and analytics providers who want to work with us and trying to get hold of that very valuable data that we collect out of the network infrastructure. So some use cases, I mentioned those already. Provisioning of network services for virtual machines can be fully automated through that solution. We created a location-based web filter solution in cooperation with a web filter company who is strong in the K-12 market here in the US, iBoss. As students walk from the dorm into the classroom, we basically block social media capabilities based on their location. That is done via those APIs. Mobile device management, we have integrations with AirWatch, Mobile Iron, McAfee and Casper, JMF, to automate the provisioning of network services for managed mobile devices and restrict or grant access based on device status, private, business-owned devices, jailbroken, not jailbroken, etc. So again, an automation of provisioning is possible using those APIs. Here it's not an on-premise integration, it's mostly with MDM, it's a cloud-based integration where the MDM software sits in the cloud, our management system typically sits on-premise, and again using an XML REST or ZOAP-based scheme to do so. Yeah. Okay, we talked about that already, so you will see that in more detail as part of the live demonstration. The UI itself allows us then to take all of the data that we collect about users, devices, locations, as well as applications, and combine it in one comprehensive UI. As that data also provides location context, we can also start to present application usage data by location, whether it's geolocation or in a stadium, we can do it by section, different sections, different application usage, present that. We can slice the data by business role, so different business functions, different devices, server functions, and even down to the user, which is most of the time not that interesting, as you get basically too much data. You are more interested in intelligent aggregation of data than particular user data. That only comes into play in most of the time in troubleshooting scenarios. Yeah? We use different presentation layers for that to make it obvious what's going on. What you see here is a tree map presentation of our application mix in our own network. So you see we are heavily CIFS centric from a storage perspective. We are in the process of migrating back from Google Mail to Outlook. So you see that reflected here. So Outlook is stronger than that. And again, you can drill down from those presentation layers as well. What's also interesting, we will see that later on as we go to the live demonstration, is the presentation of data volume by application versus number of flows by application. So the typical bandwidth consumers are our storage, whether it's on-premise storage or cloud-based storage solutions. In terms of number of flows, DNS, SNMP, and ZIP, as well as some other chat protocols, provide or are responsible for the vast majority of the flows that you see inside of your network infrastructure. So the distribution of flows versus bytes on a per application basis is dramatically different, surprisingly. Yeah. Okay. As you drill down deeper into the solution, as we said before, we can go down to the user level, find out where he's located on a per application base, see bandwidth and flow consumption here, and also detect malicious applications like BitTorrent and others, which we also found as part of our beta program in our own network infrastructure, which was also interesting to see. Yeah. So beyond that, response time measurement is also something that is part of the solution itself. So as part of the DPI process, we also timestamp network and application response time, network response time based on TCP, SYN, and SYNAC packets coming back, application response times. For HTTP, obviously easy to do, and we are working our way through all of the major applications that we think are important, RTP, DNS, and others as well. Okay, that's the management layer. Questions around management paradigm, what we do, APIs. As said, so if you have been part of that other network field day, you already know the ideas behind a lot of those things. So I think that resonated last time.
We've all done a lot of SDN, so we're all very flow-centric, unlike some people.
Sorry?
So we've all done a lot of talking about SDN and OpenFlow. So a lot of us are very flow-centric, so we get it. Yeah. Imagine you often talk to people and they go, what do you mean by a flow?
Yeah, so you typically need to start from scratch, but SDN did do us a big favor by reintroducing the importance of a flow-based architecture and the notion of flows into the system. On the other hand, most of the talks around flows in the context of SDN have been centered around a very coarse definition of flows.
Yes.
And we basically go the opposite. We go into a very fine-grained flow definition that gives you a lot of visibility, but is also challenging to manage from a system level. But we think we figured it out. We are in our 5th generation of flow-based ASIC architectures and system architectures. And obviously with traditional TCAM-based technologies, you're pretty limited. Yeah, so.
And I think it's funny that, not funny, but I think it's interesting to see that Cisco ACI is validating your approach too.
Yep.
So your chipset looks very similar to what Cisco's promoting with the ACI strategy and with their APIC chipset, or I can't remember what it's called particularly, but you know.
Yeah, exactly. So
that sort of, enhancing the core silicon with flow.
We are watching that closely. That's really interesting. It goes in waves, so to speak.
I imagine you're giggling and going, "Oh, look!"
It was actually all of the flow-based architectures were huge in the late 90s.
Yes.
Everyone was going flow-based. That was the only way to get to the speeds that you need to get to get the first layer 3 switches out the door. But then over time, it was abandoned. By a lot of vendors, basically most mainstream switch vendors, but it's coming back. So,
and I think the other thing too is that a lot of what you're looking at in Purview actually harks back to Cabletron in days gone by, and that it was where Interisys comes from, of course, and it all seems very familiar to me. It seems
it is familiar. Yeah.
That whole,
but the whole the new entity and also Legacy Extreme was heavily flow-based in the late 90s, early 2000s.
Oh, it's not a bad thing. I'm just saying, you know, there's a 20-year pedigree of doing management apps and so forth in the Extreme Interisys tie-up, which is it's a good thing. Right? You didn't just invent this last week and still working out the bugs. This is
that had a long ramp-up phase, and as John mentioned, for the new combined entity, that management framework and all of those capabilities are available right out of the gate. So we are coming out with a release this month, basically, which fosters and facilitates most of the integration from a management perspective right away. Yeah. So we feel that we are in a pretty good shape here. Yeah. Okay, the third solution component, the engine itself. Again, my name, Markus Nispel, Vice President, Solutions, Architecture and Innovation. Purview engine, the third solution component beside the ASIC technology, the management framework, One Fabric Control Center, that is important and that makes up the solution itself. So as said before, the technology is derived from our intrusion detection and prevention products. So we thought initially we just take the engine, repurpose it, and we are done. It resulted in a total re-architecture of the engine itself, but we still were able to carry a lot of technologies forward. And the engine itself gets the mirrored packets on one hand, does the packet decoding, and then applies the application fingerprint. So we have different fingerprint techniques. We can do traditional signature-based fingerprints, where we can also match multiple signatures at the same packet and payload at a time. We have heuristics-based technologies in place. We have traditional port-based and IP-based fingerprints in place, so that's not that really interesting on one hand. And we also have what we call web application rule mechanisms in place that automatically extract host name and common name out of the HTTP header and dynamically creates new application definitions based on those new host and common names, as well as specific URLs and URIs.
So you're able to monitor, you're able to monitor network and application response time for everything flowing through the network on an ongoing basis.
Yes. Yes.
And store that for historical and look back and all that kind of thing.
Yeah.
Cool.
So we do that as well. What we also do is what the system also needs to do, because typically the netflow doesn't provide you with that information. So it is part of the DPI engine itself. So the DPI engine timestamps it and stores it upstream, and you will see that as part of the demonstration as well. What we also do, what is also very valuable from a troubleshooting perspective, we extract metadata from the application flows, and specifically on the HTTP side, we get things like user agent string, browser version used, hostname, common name, talked about that, certificate information, but we are also expanding our application decoders on an ongoing basis. So we obviously decode today LDAP, radios, and Kerberos, so we get user mappings, location information, and things like that right out of the stream. DNS decoding, iSCSI decoding, and we are looking at a series of other interesting protocols. ZIP is obviously there, ZIP RTP, so you get calling station ID information, caller ID information from a ZIP perspective, and depending on where the solution is used, we obviously try to expand those decoders on an ongoing basis and find new use cases based on the data that we are able to extract as part of that exercise as well.
Are the telephony teams interested in that? Because you mentioned SIP, and I didn't know if that was something they wanted to look at.
Sorry,
your traditional telephony teams, right? You're looking at folks that traditionally have managed like PBX environments. But is that something that they want to look at, or is that still strictly a network task?
Yeah, they also want to look at it, but it's just starting. So they have their own collection mechanisms to get more precise data on mean opinion score and other voice quality terms.
That's what I'm driving at.
But interestingly enough, what we can do here is we can make a clear distinction whether it's a network or an application issue. So which already helps the network team to defeat themselves and defend themselves against the application team. So interestingly enough, we talk a lot about analytics, and we have a lot of customers really interested in that, but we also have a large portion of customers interested in just that specific feature, being able to tell right away, is or was it a network or an application problem, because then your troubleshooting process is much more streamlined than before, where you have days of finger pointing against each other and no one is really willing to admit that it was his fault or her fault or whatever.
Well, it's always the network. So.
Yeah, it's by default it's a network, because that's why this resonates really well with the network teams.
But you're really gathering that from everywhere in the network simultaneously then, right? It's not like you're relying on one choke point that everything's flowing through. So that's kind of a big deal, right?
Yeah.
Because
well, you don't have
you're
to
getting
have
it from
one
everywhere. You've got it
monitoring box.
historically. So now when you get the call that the application was slow this morning from 9 to 9:15.
Stop dumping packets to a server.
Yeah.
Exactly, right. You don't have to transport it all back to somewhere. And
It also
And the nice thing, it's end system agnostic. Sorry.
that also assumes you have an end-to-end platform that has the right processors.
Yeah, sure.
Because with the TAP model, the only effective
With the
way
TAP model, then you have only a choke point
points.
solution.
Yeah.
So that's also for us an interesting argument to convince customers to go from an initial choke point deployment into a more pervasive deployment. And that also helps subsequently for policy enforcement, as you want to be closer to your endpoint over time.
And even with the choke point solution, you know where the end systems are. So from a location perspective, based on your end systems, you can say this group of end systems in this location is getting this response time. This group in another location is getting a different response time.
There's still a lot of data. It's just not as compelling.
Right.
Yeah, exactly. Yeah.
So
it's tough to find those choke points, then or you're backhauling data across the network to pump into monitoring systems.
So we're digging into this really deep, and I'm cool with this, and I like everything I'm seeing for it. And this is a lot of data. We've had a discussion already this week about, oh my God, so much data, but you're not doing anything with it. You guys are clearly doing a lot with that data, which is the impressive part.
Yeah.
My question is this a product that you guys plan on selling as a product, or is this just a gateway drug to Extreme Networks? Because if it's a product that you're trying to sell externally, are you going to start merging with other flow-based solutions to pull data into this and do that? Because if so, this is awesome. And I can see lots of really amazing things we can do with this. If this is a gateway drug, that changes my perspective a little bit.
Yeah.
It has to be both from two perspectives, right? So there's not enough of our infrastructure out there for us to move the needle a whole lot if we're just saying, hey, gateway, right? I already have a mic. It's really a matter of how can we service more customers with our technology, and I think we have to be able to provide a solution that's going to allow us to go more broadly with it without telling customers you got to forklift your infrastructure in order to get any value out of it.
Well, I'm glad you guys said that, because you have something really powerful here. And if you're willing to open that mindset and collect data from other places through standards, I know you're not going to get your 100 million flows or whatever, but neither here nor there. If you're willing to do that, you've got something very, very compelling that you don't have to fight the battle against other iron. You just get to say, this is a cool product and we win with it, plus we have iron.
Yeah, absolutely.
Actually, we did that already as part of our network access control offering, where we totally opened up to third-party infrastructures, and we really compete on a standalone base, just on a software base, with common products in the market. Don't want to mention names, but the guys with a bridge finally made it work, I think, after their third or fourth approach to network access control, and in the meantime we were able to collect some of their customers on our belt, but obviously that's something that we are pursuing.
So that's already been mentioned. Does this function on existing Extreme Networks installs? Like say I've got the exit or something.
Yeah. So that would be the tab-based deployment mode that we use.
This is only for the Terraces.
The CoreFlow based.
If it's CoreFlow based, yeah. But what you can also do is, as you deploy network access control on an Axos infrastructure and you use those tabs, suddenly you get very interesting data dynamics, because you collect all of your user device information and location context from the access layer, and you combine it with a data collection stream, application flow collection stream coming somewhere from the core, from your choke points, or from a presentation layer perspective. You can hardly tell the difference initially whether you have a pervasive deployment or not. That only makes a difference as you don't obviously get peer-to-peer traffic if you're just at choke points, and when you do want to do policy enforcement subsequently, that makes a difference. But initial analytics is pretty close. whether it's overlay or tapped or whether it's pervasive. Yeah, but obviously that changes over time.
So you're getting data from a lot of different points in the network.
Yep.
It seems like deduplicating data would also be a challenge.
Yeah.
Because you see the flow from 2 or 3 different points in the network. You know, how do you make sure that
First release, we don't do dedupe actually. The solution to that is you have to have a good collection strategy. That's our setup at this point in time.
And you put that on us as administrators, or that's?
We have a 50-page design document that recommends a specific deployment model that avoids that scenario. Yeah.
Sort of like the age-old rules of where to place ACLs.
Yeah, exactly. Yeah.
Okay.
Yeah, but it's especially at those high rates, dedupe isn't easy anymore. And we have as you're going with a multi appliance approach, so we have our One Fabric Control Center, and we have our NAC and Purview appliances, and you have some guys reporting to that appliance and some others here. Cross appliance dedupe is almost impossible. So most of the guys who are doing a good job in dedupe, they just try to funnel everything together in a single honking appliance and try to make sense out of that. And that's not our architecture here. So that's why dedupe, in any case, is a challenge. So, I mean, you can collect duplicate data in different domains, we call it, and report on that. But within a single domain, you need to make sure it's unique. Yeah.
But if we are within a single domain, I mean, I guess one of the points that I thought I heard you make earlier was the fact that we could look at statistics from this part of the network and see that we're getting certain, X performance here, but we're getting,
You need to do that in a multi-domain deployment.
Okay, so to get those differentiating statistics, we need to have multiple domains for that.
Yeah, but domains are reflected by those engines, but they still end up in the same management system. So we tag domains inside of our data set, so you can look at different domain sets.
That seems like a lot of deployment overhead. I mean, I like everything I see about the product, but that does seem like that's a bit of
Release 1.0, so
okay.
Release 1.0.
So I'm going to ask a question I asked yesterday. When again, we're talking about a huge amount of data here.
Yep.
You're talking appliances.
Yep.
Do the appliances house all the long-term flow data and everything, or is that getting passed back off to enterprise storage?
The appliance itself they don't store anything locally. What we do is they have an in-memory flow cache, and we do hourly in a few minutes that will change roll-ups, and that is sent upstream into the management database where the long-term storage takes place.
So it'll effectively end up in some sort of enterprise storage solution where the database lives.
Yes, exactly.
Is that a standard database?
Yes.
Okay.
Yeah.
So
we are looking at other technologies.
What is the database?
It's just a MySQL database today. Yeah.
Right on.
Yeah. So you obviously then, at one point in time, you run into scalability limits there. Then you need to see how you manage that.
Well, there's also the cost concern of the storage. I mean, that's
actually we see that already based on customer demand that we by ourselves we created a big data application. Yeah.
And it's actually not a bad thing. It's inevitable if you're going to do this type of metricing, but it's just something that has to be considered into the ROI of the product or the cost model of the product.
Yeah. We are continuously working on those items specifically. Yeah. Actually, where most other vendors struggle down at the data plane collection, that is easy, so to speak. It's more the challenge. What do you do upstream, so to speak, to handle the data volume? Okay. Are we on time? Actually, didn't turn on my timer. Oh, still okay.
You're doing good. You got 45 minutes.
Okay. Also important, fingerprint technologies. As said before, there's not a one-to-one correlation between fingerprints and applications. For certain applications, we have a series of fingerprints and even a different type of fingerprint, a series of different types of fingerprints per application to do that. Customers can modify it, so that's pretty cool. So we had a lot of positive feedback on that capability as well. As said before, we have different techniques for fingerprinting. It can be port-based, IP-based. We can use HTTP header information, but we can also use traditional signature capabilities, and also those are exposed to the user. So we have seen government agencies for using that for their own internal custom applications where we don't provide fingerprints, but also all sorts of other vertical markets where you have a series of custom applications that we wouldn't detect out of the box. And either customers can create their own fingerprints, or we've also seen that our partners are very interested to offer Purview as a solution overall, as a managed service, but also start to develop additional fingerprints based on that system. Okay, application flow details. As I said before, we are able to extract a lot of additional data from those application flows, very beneficial for troubleshooting, but also backwards. As I said before, we can also provide access control based on certain criteria. And here, operating system device type information is often included in those user agent strings, which we can feed back into our access control system. So that interface goes bi-directional. So we can push data from access control into Purview, but also vice versa, and leverage that. Yeah. Okay, in terms of deployment modes, I think we talked about most of those. So we would like to see being deployed at the access layer, obviously, as leveraging CoreFlow2 based devices here. Distribution is another good point to start, where, as you assume that most traffic is client-server traffic, you are able to effectively collect that. In the core, another option, we can scale into core deployments, or you just use it towards your data center, or pervasively and even within your data center. And we classified those as good, better, best deployment modes, which again, better than a single overlay solution is obviously going into the core, where you see all client server traffic for your internal network and your external facing traffic. Same for distribution, where you get a better enforcement point position, best at the access layer, but we can also scale inside of the data center and inside of data center traffic, which requires you to have specific speeds being supported. Okay, summary. I think we talked about it in length. Application visibility and control at layer 7 pervasively with an open architecture, open and customizable fingerprints at terabit speeds for millions of flows, additional contextual information being included. It's a true DPI solution, so derived from our IDS technologies in the past, so totally port independent. And it's a single architecture across the board, which is also, from our perspective, very, very beneficial. So that's it, basically, from a PowerPoint perspective.
I have a follow-up question around deployment architecture. Going back to it doesn't run on extreme hardware, it runs on Enterasys hardware right now.
Yeah, there's only extreme.
Well, it's all extreme now, I get this. So that's where the question's going. So you gave the entry point for a switch at 30 grand that's enabled with that right now. Yeah. You're also saying that optimally, if you're going to do an extreme end-to-end network and get all the benefits of this, you put this down at the access layer. $30,000 pancake, 24, 48 port switch is a little pricey at my access layer compared to anything else in the market. What's the timing that you guys are going to move this stream processor into the rest of the line? I know it's a really recent acquisition, but what's the timing?
Yeah, I can't comment on the time. John is in a better position to do that. I'm always careful, but I'm always too aggressive with roadmap items. But I can tell you that in our existing portfolio, we have a chassis-based product for the access layer that is price competitive at the access layer as well. So it's comparable to, don't want to mention other names, but there's a product, 4500, you might have heard of, that can be deployed at the access layer. And we have a class of product that is in a similar space. At this point in time, getting it to a cost competitive fixed switching solution is a challenge.
So I was going to mention the wiring closet chassis as well. So that's going to be a key component. The other thing that both companies were in the process of looking at next generation chassis, both in campus access and aggregation, as well as in the core and data center. And what we've effectively done is sort of collapse those programs into a single program. And one of the goals is to make sure that those programs have next generation CoreFlow technology as a part of that. But as you know, with any program of that size, that's a multi-year effort. One of the things that we're doing at is to try to create ways in which to get access to this technology for the current exhaust-based users at lower price points through some promotional type activities. And I think, as you alluded to as well, there's a lot of value in us being able to spread a lot further beyond just our current customer base and current hardware infrastructure. So being able to bring it in as a tap, so to speak, and being able to do that in a way that is approachable is really important to us. We'd much rather, at this point in our life cycle and where we are as a company relative to market share, gain a lot more customers and introduce them to this type of technology than ensure that we are getting the top dollar for that.
And I think that's the right answer, but at the same time, you guys acquired them for a reason. At a time when flows are driving the entire industry, you happen to acquire the one major flow switch manufacturer left in the market and all their applications and all their IP. So I can't think that your plan isn't to roll that into the rest of the architecture.
Yeah.
My question, or I guess my curiosity is just back to the point, how much can you drive that cost down to drive that all the way down to all the user base? And it'll take time.
Yeah. I mean, so trust me, that's an active pursuit right now to figure out how low we can bring it. Obviously, the merchant silicon space and in the fixed product lines, you're driving different ASICs, out of Broadcom or other vendors at different cost points based upon what sort of feature set you're providing. There's likely only so far down that fixed lineup that you can go, and we're working to figure that out.
Okay.
I would love to, given that I was part of the acquired company, I would love to bring it everywhere. But at the end of the day, we're going to be inhibited by costs to some extent, just because the current instantiation of that ASIC is a pretty decent sized ASIC meant for chassis products.